In this video, we're going to have a look at volcanoes, and just a reminder that volcanoes occur where plate tectonic boundaries occur, and that is why volcanoes and earthquakes often follow a very similar pattern of occurrence, because if plates are coming together or pulling apart, this is going to generate molten rock, either coming straight from the earth itself, already molten if the plates are pulling apart, or as plates come together, you might have molten rock being forced up through two plates coming together. So we've got volcanoes and earthquakes appearing at the same point in the earth. And one of these major areas where volcanoes are seen is the Ring of Fire, and that's the boundary of the Pacific Ocean. But there are also volcanoes happening at divergent boundaries where plates are pulling apart. So right at the bottom of oceans, like at the Mid-Atlantic Ridge, you get volcanoes there too. You will also have noticed that sometimes you get volcanoes in the middle of tectonic plates, which seems a bit odd. But that's because there are hot spots within the mantle. So particular zones in the mantle where the rock type is slightly different and you get a lot more of an upthrust of hot molten rock, magma, and Hawaii is one of those examples. And also there's a line going across Australia of ancient volcanoes where there was a hot spot that as the tectonic plate that Australia was on drifted over this hotspot, volcanoes erupted through the crust that made Australia. So let's have a look at volcano anatomy. So this is a cross-section through a sort of classic volcano. There are different types of volcano, but they all have similar features. So if we look here, we can see that there's a magma chamber deep inside the earth, and that's where the molten rock is sort of gathering. And as it pushes up through the vent or the chimney of the volcano, then the magma can flow up through the existing rock, up through the shape of the volcano there. So as the magma reaches the surface, it changes its name. It's now called lava. And the lava can flow down the side of a volcano. Some lava is very viscous and thick and slow moving, and some lava is very thin and runny and fast moving. In addition to lava coming out, there can be, if it's an explosive volcano, you can end up with ash clouds, which are very fine particles of rock being sent up into the atmosphere. And also sometimes we've got here volcanic bombs. These might be burning hot pieces of lava that have been sent into the sky. It might be pumice rock, which is very aerated rock that's been sent into the sky. And these are very dangerous as they rain down because they're very heavy and they're very hot. And the last two features that we will label on this diagram, we've got the crater. The crater is the usually sort of circular opening of the volcano where the magma is coming out and turning into lava. And then the cone is the actual shape of the volcano. So you can see this one's a very cone-shaped volcano. So you can see a lot of these classic features on this picture here. This is a picture of Mount St. Helens. It actually used to look very much like a classic volcano shape. It used to look a bit like this. And then in the 1980s, it erupted and it actually blew the top of the whole mountain off and it caused a vast amount of destruction. I'll show you another picture in a little bit with, you can see all the trees have been blown down, the force of the explosion. And now there's a little mini volcano in the middle and you can see the ash cloud here. Coming out of it. So we have a very large crater at the top, what was the mountain, and the ash cloud is still an active volcano. So let's have a think about why you'd want to stay away from volcanoes. Volcanoes obviously have lots of lava coming out of them. It's incredibly hot. You cannot stop it. It's heavier than water, so it's really difficult to divert. And you can see in these images that buildings have just and vehicles and towns are just being taken over by flowing lava. Another problem, there's the ash. You can have ash clouds that go high into the atmosphere, like in the bottom right here. You can have ash clouds that go up into the atmosphere, but then they cool and they start to cascade down the side of the volcano in a pyroclastic flow. And this is an ash cloud chasing a car here. Pretty scary because it's not just ash. It's really, really hot, fast moving, gritty rock, and it's going to get in your eyes and in your lungs and cause massive amounts of scarring and burning and health issues. And you can see how deeply it falls. So in this picture here, we've got a meter or meter and a half of ash has layered, and this is really destructive to agriculture, to animals, to waterways. It collapses buildings because it's just heavy. It's really heavy. In addition to this, you can have mud flows. You imagine the top of volcanoes are covered in snow and ice. And as the hot gases and the hot lava come out, they melt that really fast. And you get big flash floods full of mud and ash coming down the hill. That's called a lahar. And that's very damaging. And then I told you about Mount St. Helens before. When it erupted, it was so forceful. Look at the way it flattened the trees for about 40 kilometers around the volcano. Trees were just absolutely defoliated and flattened. So you really wouldn't want to live near a volcano. So you've got all these issues, lava and ash, and you can also have tsunamis, flash floods, earthquakes, mud flows, rock falls. Who would live near a volcano? Well, there are lots of good reasons to live near volcanoes. For a start, they're quite pretty. They have great scenery. The land around them is incredibly fertile, bringing up all these minerals from the center of the earth. When these rocks erode, the soil becomes incredibly fertile. Tourism, people want to visit volcanoes. It's very pretty there. There are hot springs to bathe in, so there's lots of employment. And you can also get almost free energy. Once you've built your geothermal energy plant, you get hot water coming straight from the ground, and it can drive your turbines and generate electricity for you. There's also a huge amount of resources near a volcano, so you can mine for minerals that you can't find anywhere else in the world, and you can sell, artifacts like stones. These are pumice stones in the bottom left here, and you can turn all that ash into products like soaps and all sorts of things that people will want to buy. So those are all great reasons to live near a volcano. And here's an example of why it looks so pretty. This is an awesome, huge volcano. There's a massive crater all the way around the outside, and it's been filled with water. It's a massive lake. It's called a caldera, and then there's a mini volcano in the middle, just poking through like an island. So it's actually a little bit less unpredictable compared to earthquakes, because you can actually predict volcanic eruptions. These are all different ways we can monitor volcanoes. And in the picture in the top, you can see that the earth has started to change shape and heat as a volcano as a magma chamber is starting to fill up underneath an active volcano. So you can live there without, as long as you're listening and you've got people monitoring actively, it's not going to be too unpredictable. Although when it does go horribly wrong, it goes horribly wrong in a big way. So hopefully you'll be able to build up some arguments for and against living in a volcanic region, as well as being able to argue why earthquakes and volcanoes happen in very similar places.